before we move on? No? Okay, now this is the same problem we had last time. So for the GRE test, a sample of 10 students took the exam, found that the mean is 1.4 and the standard deviation is 11. So again, we're gonna put this thing down. We're gonna say that our see n is 10, x bar we're told is a 144, and we're told also the s, the standard deviation, which is 11. Okay. Now it says now, is there evidence to conclude that the standard deviation varies more than 8.8 at the level of significance 0.05 using critical value method? All right. Now, the claim says what? Is there evidence to conclude? So that's the claim right here. It says the standard deviation varies more than, so that means that the sigma is bigger than 8.8. If that claim is not true, the alternative claim, then what is the opposite of bigger than? Well, it is a smaller or equal 8.8. All right, now step one, based on that, where's our H1? Again, H1 always has the inequality, so sigma is more than 8.8. Right there, we know this will be a right tail test, RT, right tail. Okay, this is called a right tail. When we draw it, we're going to draw air on the right. Okay, and if you know that H0 is always equal, so sigma is equal 8.8. I mean H1, I'm sorry, H0 is 8.8. Alpha, what we're told is 0.05, so that's easy. Okay. Now, step 3, compute the appropriate test statistics. Well, we're talking about what? We're talking about the standard deviation. Okay. So look at your formula table, your formula sheets, and look for the. This is the standard deviation. Okay. So look at the formula, and you should see the statistics formula for the standard deviation or variance is chi-square. We use chi-square, but this is for the standard deviation or the variance. So we use chi-square. It is chi-square statistics. It is n minus 1 s squared divided by sigma squared. Okay. So this should not be that hard to do. Okay. From what we gathered earlier, we know that n is 10, so 10 minus 1. And then s we're told is 11, so 11 squared. I remember this is s, this is x squared, don't forget to square, divided by sigma squared. Sigma is 8.8 right there, so 8.8 squared. So use your calculator for this. If I do the right, if you do it right, you should get the 9 times 11 squared divided by 8.8 squared. You should get the chi-square to be 14.0625. All right. Now, next step, we're gonna again find the critical value. This case, since we're talking about chi-square, we're gonna look at chi-square and compare it to the test stat again. So same procedure last time. Now I'm gonna draw here. Right here I said it is a right tail test, so I'm gonna draw on the right side only. So this is a skew right. Forget. So here, skew right. And then it is a right tail test, so I draw only error on the right. So here's our chi-square critical value, sub-zero. Don't forget, right? The critical value, we use the word, we use a sub-zero to describe that. Okay. To give the chi-square critical value, you will need, again, the df, the degree of freedom, df, which is n minus 1. So our degree of freedom is 10 minus 1, so it is 9. We also need the area to the right. So alpha is, we're told is 0.05. Now, it is only a two-tailed test. I'm sorry, this is only a right-tailed test, so no need to divide by 2. Okay. We only divide alpha by 2, this guy by 2, if we have right-tailed test. Okay. We have a two-tailed test, then, I'm sorry, we have a, let me do it again. We only divide alpha by 2 if we have a two-tailed test. Okay. In other words, when H1 is not equal, okay, so like sigma is not equal to 8.8, then we use the two-tailed test. Then we have to divide alpha by 2. Okay. If we have a left tail or right tail, then we don't need to divide by 2. So we're going to keep the alpha at 0.05, and this area here, it is, right, this is the critical value, sorry, critical region, don't forget, right? Critical region, critical or rejection region. Again, critical region based on the critical value, so it makes sense. So okay, so with this truth thing right here, we're going to go to the chi-square table, and then we're going to look for our area on the right. For alpha is now our area on the right, okay, or to the right. Because we have a right tail test, this is a right tail, okay? So if you look at your table, let me go ahead and do that table real quick. So let me show you that one. Remember that I'm looking for a df of 9, and error to the right is 0.05. So I'm gonna go back to the table. Chi-square table, this is a T table. This is the chi-square table. I'm looking for the error on the right of 0.10. So here we go, we got 0.10, so right there, error on the right is 0.10. Wait a minute, it's not 0.10, it's 0.05. I read it wrong, right? 0.05, not 0.10. Okay, so make sure you get that correct. So make sure we got correct alpha. Alpha is 0.05, so the error to the right is 0.05 because we have a right tail test. The F is also 9, or the degree of freedom is also 9, so 9 right there. We're going to match this two. So now, just like this, this is our critical value chi-square, which is 16.919. Okay, so from alpha 0.05, which is error to the right, and the degree of freedom of 9, together we found that the chi-square is 16.919. So we want to go back to our worksheets, and we're going to write the chi-square as 16.919. Now, step 5, we're going to use the test set to test. Okay. So you can redraw this if you want. If not, you can just use the one that you already drew here, right? I just to draw it, so I'm just gonna draw it quick here. Okay. So here we have the critical region, or CR for critical region, or RR for rejection region. And the chi-square for us is chi-square critical value is 16.919. I'll test that from the step number 3, which is 14 point, right? So 14.0625. So chi-square is to test that. See the test statistics, that is 14.00625. Okay, so we're gonna say, well, where is this thing gonna land it at? Okay, so we're gonna go 16.9, and the way this skew to the right graph structure is from a small number, so it's like a small number, right, to a large number, small to large. Okay, so the left number is smaller number. If we go to the right, then getting larger. So if I were to look at this, my 14.04 is gonna be in right here, right before it, right there, okay, right there before the 16, and the test stat is 14.0625. So look at this graph. We're gonna say that again, we're gonna fail to reject. We're gonna say fail to reject 80 because CB, because the test stat or the test statistics was not in the critical region. Huh? Okay, lastly here, we're gonna again make the conclusion. So we base that on two things. Okay, again, the result from step 5, which is fail to reject. Okay, from step 5, fail to reject, we got that. Fail to reject H0. And then our original claim. So original claim. Well, original claim saying that sigma is bigger right here, right? So right there, let me remind you there here. So claim says sigma is bigger, so that's our original claim. So here we said the sigma is bigger than 8.8. So this one still does not contain equality. So with that, we're gonna say that we're gonna use the claims, and we're gonna say that conclusion. You can look up the table yourself and make that claim. Let me erase this thing. So again, the original claim does not include equality, or does not include equality. So based on those two things, we now can make this conclusion. Okay. Again, look at the chart yourself, and we can say that there is not sufficient evidence to support the claim that that the standard deviation vary more than 8.8. It's gonna put the wording in here. Okay. So with this, we say that there's not sufficient evidence to support the claim that the standard deviation varies more than 8.8. And that's all we can say about the conclusion. The rest are based on we're gonna leave it to the spectator on to compute to argue on that. Okay.